So I want to thank Gene for the very gracious introduction. So you take an entire lifetime, take all the good stuff, extract it out, put it in a thimble, and repeat it. So I'm standing backstage, and it's like, man, I'd like to meet that guy. Yeah. But anyway, whatever swelling ego I get, I have 3 teenagers at home. We'll bring it back and check when I get back to Boston. So quick question. So you guys have had a long day, heard a lot of stuff, and I'm standing between you and happy hour. So why are you here? No, I mean that seriously. So before I start talking, think about what do you want to learn. So because otherwise, I'm just up there waving my arms and talking real fast. So Anchor, what do you want to learn? All right, so take 10 seconds. What do you want to learn? All right, so now let's talk about Lean, which I think is part of an influence on Agile and DevOps and something like that. And as far as my history with Lean, the reason for the bow tie is not to look like a doctor. I play one on TV. It's actually when I started studying Toyota many years ago, I wanted to dress up when I went to visit facilities. But I also want to be able to get into the work. And if you try to dress up with a tie and get into the work wearing a long tie, wraps on spinning things. Anyway, the bow tie was the compromise. So anyway, in terms of Lean, you've all heard the term. Real quick, make a mental check. Here are things Lean works for, and here are things Lean doesn't work for. All right, again, take 5 seconds. All right, now let's move on to the next set of questions. Why Lean? I mean, just to give you a sense of things, so last week I gave a talk at something called the Lean Construction Institute. Lean is part of your conversation. I'm giving a talk next week at a Lean manufacturing event, and then after that, Lean healthcare. So why the interest in Lean? And let me just tie this down. You're allowed a one-word answer. All right, so why Lean? Back there, white sweater, red shirt, I can't tell exactly. Yeah, I'm pointing right at you, about 10 rows back, slightly over. All right, the guy who raised his hand, why Lean?
I don't know.
All right, that's good. Over here, blue shirt, why Lean? You who just looked up, why Lean? Why do we talk about it so much? Louder. Quality. Efficiency, quality, efficiency, what else? Waste, quality, efficiency, waste. Anything else? Learning. All right, quality, efficiency, waste. All right, so let me just say that is part of the reason, but the one-word answer I was looking for is this, Toyota. That's why we talk about Lean. And let's really qualify and quantify why we talk about Lean because of Toyota. Because Toyota absolutely positively decimated its rivals in the U.S. auto market. Destroyed them. Right? I mean, until Toyota shows up in the 70s and then with a real presence in the 1980s, GM, Ford, and Chrysler, happy-go-lucky, la-da-da-da-da, doing what we do. And then Toyota shows up, and we know the results. GM in bankruptcy, Chrysler in bankruptcy, and Ford stumble along. So let's just get some scale in terms of what it means to decimate one's rivals. So Toyota, do you know when Toyota first came to the U.S. market? Call out a year. 78. Actually, 1958. The Toyo Pet. Anyone hear of a Toyo Pet? All right, good reason, because it stunk. All right, here's to add some qualification to what it means to stink as a car. If you're in a Toyo Pet and you need to get to the top of a hill, bearing in mind that Toyota's first U.S. market was here in California, if you need to get to the top of the hill, odds are better in reverse. All right, so imagine here, San Francisco, going home, Embarcadero, or whatever it is, trying to get home, drawing, and there's no guarantee. Right? This is just the odds are better. But anyway, now to add some quantification on the qualification of really stink. So when Toyota went to make a Toyo Pet, their productivity was 1/8 the world standard. So if it took 4 guys at Ford or 4 guys at General Motors to build a car, it took 32 at Toyota to build a worse car. All right, so that's 1958. 1962, and again, there's a reason the picture has the date has no picture. It's because after 1958, most people are not aware about Toyota products in the United States. But from 1958 to 1962, Toyota went from 1/8 as productive as the world standard to equal in productivity to the world standard. By 1968, they were twice as productive as the world standard. So the same 4 guys making a car at Ford or GM or Chrysler or Volkswagen, I don't know what they were doing at Volkswagen, Farfignuga, now I know what that means, right? Never knew, but now I know. Is it lie and cheat and steal? Wait till I get going on General Motors, if you're growing it now. All right. So for the same four guys making a car at Chrysler, Ford, General Motors, or anywhere else, it's two guys at Toyota. And then Toyota comes back to the U.S. market in 1973, and I think that's when most of you said, oh, they came here in the early 70s. So Toyota shows up with a car in the 1970s, and it does something incredible. First of all, it's really affordable, and that's the consequence of half the guys making twice the product. You don't have to charge as much for the same car. But the other thing is it's wickedly reliable. So those of you who are old enough to remember this, that before Toyota showed up, the assumption was that if you bought a car, you found a mechanic for it. And if you knew someone who owned a car, you knew where they parked the car based on the stains of leaks in their driveway. And Toyota shows up with a car, and it goes something like this. You buy a car, and if you keep replacing the gas, it continues to run. The American auto driver had no idea about that concept. Well, I just put gas in, it keeps going. And again, just to anchor this, when Toyota first advertised their car around this value proposition of affordable reliability, the ads went something like this. Guy'd say, oh, this is my Toyota. I drove it 50,000 miles. And then those guys, wow, he must take impeccable drive only in the sun. And then someone would show up with the car. I've been driving 75,000 miles. And it's like, oh, that's incredibly lucky. They got the luck of it. And then the next one would be the 100,000 mile car. And then the guy would come in with his 200,000 mile car and have a little mud and a little dent on it to show its age. And at that point, and for those of you too young to realize this, you have to actually stand up and turn off the TV, but you turn it off in anger. It's, they're lying to me. 200,000 miles, that's impossible. But anyway, it turned out to be possible. So that's 1973, wickedly affordable reliability. 1985, and this is when people started to really pay attention to Toyota, they realized Toyota was updating its product on a 2-year clip rather than 4 years for everybody else. So think about this. You're going to buy a car, and you walk into a Ford dealership, and you look at the Taurus, which is the prime mid-market car at the time. You look at the Ford Taurus, and it could be a 4-year-old product. Now, again, raise your hands if you want to go out and buy something 4 years old, a computer, iPhone, whatever else it is. You walk into the Toyota dealer, and even if at the very, very, very end of the model run, it's only 2 years old. All right? End of the Ford Taurus. And then through the mid-'80s, through the mid-'90s, Toyota has this huge, huge expansion of domestic manufacturing capacity. So this is what absolutely devastate your competition looks like, and this is not the end of it. All right, so then we know Toyota's been wickedly successful on the Lexus. Again, 1989, there were no Lexus. 1991, it is the best-selling luxury brand in the country. Scion, absolutely dominant in getting the 20-somethings. But let's talk about introducing new technology. All right, so here's the thing. You guys introduce new technology all the time. Now, very often, you'll be introducing a new technology to solve a problem that other people have identified. And so the competition is getting to the better answer faster. And so in the case of emissions and fuel economy, Toyota and General Motors and the rest of the auto industry, they saw exactly the same problem. And they arrived at exactly the same solution. So the solution they came to was hybrid. So you put a smaller internal combustion engine under the hood, pair it with an electric motor, overlay some kind of software and energy management on that, and you get much lower emissions and twice the fuel economy. Same problem, same answer. Now here's the thing. Toyota got to the right answer faster and continued to update its answer much faster than General Motors. And again, to scale this, so since the introduction of hybrid, General Motors has sold approximately plus or minus 70,000 copies of the Chevy Volt. In exactly the same period, Toyota has sold nearly 7 million on 21 different platforms in 6 generations. Again, think about this. You and I are trying to solve the same problem. My answer gets a penny, your answer gets $1. That's what we're talking about in terms of the ability to utterly decimate the competition, why we talk about Toyota in the background implicit to the conversation about lean. It's something about bringing value to market much, much faster than anybody else has the capacity. So that begs the next question. Well, anyway, we'll get into the engine, but here are some of the rewards. So even today when Toyota, and again, back in the 80s, 90s, if you said lean, why are we talking about lean? Everyone in this room would have said Toyota. It's obvious, it's Toyota. The fact that no one in this room said Toyota at first is because Toyota's kind of passé, because we're so accepting of their presence in the marketplace. But to give you a sense of things about apples to apples, level playing field competition and the ability to bring value to market, Toyota sells plus or minus the same number of cars as Ford, same model segment, same against the same, matched up in brands, matched up in regions. When Toyota sells a car, they make $2,700 per unit. When Ford sells a car, and they're number 2, they make $900 per unit. General Motors, Chrysler is way behind that, and again, we just don't know about Volkswagen. All right, but this is not just an auto thing where even in a hyper-competitive industry, the rewards for being first and best are enormous. So in the case of consumer electronics, again, show of hands, who has an Android phone in the room? All right, how many people have an OS in the room? It's about right. It's the OSs are about 1/5 of the world market in terms of units sold and revenue. That's fine in terms of, but Apple makes 92% of the profit. Now, why is that? Because they're just enough ahead in terms of new form, new function, new feature connected to a supporting ecosystem that we're willing, like cultists, we're willing to stand on a line waiting for the next one to come out where we treat the Android phone as a commodity. And we could talk further about Intel. Moore's law, doubling the capacity of microprocessors every 2 years. You think it describes an industry, it simply does not. It's Intel. All right, so those are the rewards for getting value to market at speed. And fundamentally, here's the thing. If you and I are trying to do the same work, and you're much better at it than I am, your knowledge is better, your skills are better, then it has to be somewhere along the way you learned better and faster than I did. Because we weren't born with this knowledge of how to create an iPhone and put it into an ecosystem and update features and form and touch with your thumbprint. It's something you learn to do. And if you're always ahead of me, if you're $2,700 per unit versus $900 per unit, it means that you are just consistently learning better, faster, with more discipline, more broadly than I am. So, again, putting on my sort of academic nerd hat on this, is we like to talk in terms of phenomena and the underlying theory. So the phenomenon is organizations trying to solve the same problems by bringing value to market at speed. The phenomenon then is, one step further, certain organizations being able to do much better at that than everybody else. And the theory is it's because they learn much better and much faster than anybody else, because that's all that's left. It can't be access to raw materials because they're available to everybody. It can't be access to technology because folks like you will sell it to everybody. All right? And it can't be access to protected markets because you can sell to anybody. The only thing left is knowledge. So then we have to get into the question, what does the learning engine look like? So anyway, to detail a little bit on the learning engine, let me give you an example. The guy you're seeing is Hyman Rickover, considered father of the nuclear navy. Now let me tell you a story about Hyman Rickover, Admiral Rickover, father of the nuclear navy. So one day, young engineer Ted is on his way to a design meeting. And let's say it's a 5:15 meeting, just to anchor us here. And on his way to the meeting, Ted, he's carrying his drawings, he's got his calculations, it's back in the day, so he's got his slide rule and this thing and that thing. And he's headed towards his 5:15 meeting, and his boss ambushes him in the hallway and he says, Ted, what are the results of your 5:15 meeting? Boss, it's 5 after 5. I don't have results. That seems reasonable. So what is his boss's response to that? What's a fair response? Imagine you're going to your 5:15 meeting and your boss says, what are the results of your, over here. Well, what's a fair response? Well, I'll tell you later. All right, what's a fair response? What are the results of your 5:15 meeting? It's 5:05. What's a fair, when you say that to your boss, you can say, I don't have results yet. What's a fair response from your boss? So what do you offer? Well, let's see. All right, that's a question. That's sort of a response. What's a fair response? I'll tell you later. Well, how about this? You're a moron, Ted. Is that fair? And Ted said, what? How can I be a moron? The meeting hasn't happened yet. I'm not clairvoyant. How can I have results for a meeting? Ted, I correct myself. You're not just a moron. You're a fool too. You're a fool too. And Ted at this point protests, and he keeps protesting. And finally his boss says, you know what, Ted, you're a moron, a fool, and an idiot. Now let me explain. So here's the explanation. So are you all comfortable with that? Is this how you want to manage or be managed, by the way? All right, just checking. All right, so here's the logic, because it actually makes some sense. So Admiral Rickover starts explaining to Ted. He says, look, Ted, what are we trying to do? What are we trying to do? He says, we're trying to put atomic-powered engines onboard warships. I said, good. All right, that part at least you got right. And he said, and what's our standard? And the standard was perfect. And it was the whole reason, because if you're not perfect, then you don't get the license to run these reactors, bring these warships into other people's ports. People won't trust to put their sons on board your warships as sailors if you're not perfect. So anyway, that's the reason for perfect. So then Rickover says, and what do we know in terms of being perfect? To which says, well, I have to admit, we're pretty far from know all the things we need to know, knowledge and skill, to be perfect. And that's where Rickover said, aha. And that's why you're a moron, a fool, and an idiot. You're about to go into a meeting, and people will ask questions. And because you want to get along and show like you're a smart guy and whatever else, your head's going to be nodding up and down with every question. Like, that's a good question. That's a great question. And I'm just saying how smart I am and how I agree with you and that we're buddies on this. And then you're going to give an answer to that question. I'm going to say, hey, that's a good answer. I would have thought of it too had I given it some thought. I didn't, but I would have. And then someone's going to raise an objection, and then you're going to be nodding up and down even more vigorously to prove again how thoughtful you are, that with that you would have had exactly the same objection and you got your back. And Rickover says, and here's the problem. Had you invested time in predicting the questions, the answers, and the objections, within a minute, you said, that question? I don't have that question. Where'd you get that question from? I don't understand our situation. I would never have generated that question. And you would have started having a conversation about how you had different questions. And when the answer came up, even if you anticipated the question, you would have said, son of a gun, how'd you get to that? And same thing with the objection. And Rickover's point is, within about 3 minutes of your meeting going on, you would have identified all this ignorance that's plaguing you people. And you would have called short on the meeting and said, hey, we got a month's worth of research and experiments to do to start figuring out how we can get this, at least the same questions, the same answers, and the same objections. But he said, because you haven't bothered to predict what's going to happen, you're a moron, an idiot, and a fool, because you've lost the opportunity to learn. And that's how Rickover defined moron, idiot, and fool. So anyway, carrying the TED story a little bit further. So young engineer Ted now gets responsibility for designing the shielding which goes around the reactor. Surprisingly, not a non-trivial job. And they get to the point where they've designed the reactor, they've designed the shielding, and they're ready to test it for the first time. And you can imagine what the test looks like. You've got the apparatus of the reactor. Around the reactor, you've got the shielding, and around the shielding, you've got thousands and thousands of sensors. And what do you have in the room with the engineers? What do the engineers want to do? Push the button, right? Right? Push the button. Ted, push the button. Push the button. Right? That's what's going on. Ted, push the button. They just want to run this thing and see what happens. So Ted says, hold on. Before we push the button, what are we measuring for? The answer is emissions. And let's just say arbitrarily, the number is 10. That they've talked to medical authorities, this and that. Above 10, 10 is sort of the cutoff for safety for emissions. So everyone says, oh yeah, Ted, we're measuring for 10. And then Ted says, all right, here's the deal. How do we react to an 11? So how do you react to an 11? You there in the back. How do you react to an 11? Push the button. No, you push the button, it's running. And a sensor says an 11. So how do you react to the 11? Are you happy or sad? Sad, right. Why is that? Yeah, because it's above a 10. Yeah, I don't know if you're going to die, but it's above a 10, right? All right, so let me ask you a second question. What happens if you get a 9? How do you react? Over here, how do you react to a 9? Happy. Who else is happy with a 9? What? Happy with a 9. Who else is happy with a 9? A win's a win. Let me ask you this question. This is Ted's reaction channeling Rickover. Why the hell are you happy with a 9? You designed for a 10. A 9 tells you you're wrong, right? So a 9 says that you designed for a 10 and you got a 9. It means, wow, this whole basic science we have of critical mass and chain reaction, where'd the 1 not come from? Or maybe it came somewhere else and you don't understand material properties, it deflected somewhere else and we missed it. Or maybe it got generated, didn't deflect, it got absorbed and it's causing fatigue on the apparatus inside. 9's horrible. 9's horrible. And so here's a lesson out of the hallway conversation leading into this, which is when you start to build something, you should be part of your build is prediction as to what you think will happen so you can test against it. And here's what Ted said to his colleagues. He said, 11, get it? Yeah, we should be horrified by 11, but 9 too. Because 9 is an equal indication of stupidity and ignorance, as is an 11. And so if we get a 9 or an 11, or heaven forbid an 8, I mean, 8's even worse, right? You think 8's good, right? Because the threshold is 10, you got an 8. How about a 5? That's even worse. I mean, 5, you are so far off the mark. So far off the mark. All right, so he says, what that leads is we've got to figure out, once we've predicted what we're going to get, and we've tested to see whether we're right or wrong, we have to explain why are we wrong. And in the case of this program, we have to go back. What settings did we pick? What calculations and models did we use to justify those settings? What basic science did we use to motivate the models and the calculations in the first place? Because somewhere in there is laced ignorance. Because somewhere between our basic science and our models, our calculations and our settings, we got a 9 and down to 10. All right, and so the admonition from Ted, again channeling Admiral Rickover, was that if you predict what you're going to get and can test for it and see wrong, it's incumbent on you to at least explain wrong so next time you're closer to right. All right, so that's the second behavior, really fundamental to this, learning much better and much faster than anybody else. Now, there's another story here. So taking this a couple of years forward, so I had a student, name is Tom. We got a lot of T's in here, but student Tom is explaining what it's like to serve on board one of these atomic-powered submarines. And he's describing his experience being in command of the control room, and they're following all these very complicated procedures, how to run the reactor under certain circumstances in order to get certain power outputs. And there's one monitor they're watching, and there's this very transitory spike on it, a fraction of a second. And then everything goes back to normal. What do you do? What do you do? Yeah, call it out. Take it out. Control-Alt-Delete. Right. All right. So I'll let the Windows and the Apple side of the room just clash that one out. All right. But he said, all right, so most people, if they get just a transitory spike, they say, well, return to normal. I guess everything's fine. But what, a guy like Admiral Rickover and this young engineer Ted, now an old engineer Ted, had beat into young officer Tom's brain is that you didn't plan for the transitory spike. It wasn't in the procedure. So what you have to do is call attention to it and say, hey, we're surprised by this. We didn't predict it. The test in use proved that we have a problem. So what you got to do is wake up the crew that's asleep so they can come in and help you diagnose to the cause of the transitory spike. And the reason for this, again, capability 1, see where you're wrong. Capability 2, find out why you're wrong. Capability 3 is to take what you've learned locally and make sure it can get deployed throughout the fleet so other people have modified procedure based on your experience. All right, so think about what this involves. This involves young officer Tom raising his hand, waking up his captain, and his captain then waking up his admiral and saying, guess what, we had a problem, and I want to spend all night telling you about it. All right, now, that gets us to our third capability, which is in these super fast learning organizations, absolutely positively dedicated to seeing things go wrong, absolutely positively dedicated to finding out why. Now, let me just focus on this for a second. So there's a lot of stuff going on now, which is, oh yeah, we can't get the right answer, so what we have to do is try a whole bunch of things, test them out, see what works, discard the bad. I'm baking cakes, make 5 cakes. The one that's good, I serve to you. The burnt ones, I throw away. Now, in this mindset of Admiral Rickover and young engineer Ted, throwing away the cakes is the world's biggest crime. Because the cake that worked, what'd you learn from the cake? You knew you liked the cake, that's why you baked it. You thought the recipe worked, and it did. Whoop-de-doo, what'd you learn? It's the ones that burnt, those are the ones you can learn from. Throwing those in the trash can, why the hell you do that? That's 80% of your discovery investment's now been thrown away. All right, so in terms of the capabilities of these organizations able to get way high performance because their build of knowledge and skills is just way faster than anybody else, it's got to be leader-led, because everything we've discussed so far is counterintuitive. We want to celebrate 9s. No, you don't. We want to call out successes. Yeah, you do, but you want to call out failure. This is all counterintuitive. It's not what we learn growing up. And so if you want an organization with this learning dynamic just perfused everywhere, and you lead other people, you got to show them how to do this. And let me tell, and the Rickover story with this. So this young engineer, Ted, talks about his first encounter with Admiral Rickover. 1948, they're in Oak Ridge, Tennessee. The Navy is learning about what had been discovered through the Manhattan Project. They're going to their first class, and maybe a setup like this, some, oafish professor type talking to people sitting in a chair. And everyone's dutifully taking notes. And we'll make you Admiral Rickover. So the lady on the cell phone. Come on. Really? 10 more minutes. Just spot me. Oh, she's tweeting. Keep it that. All right. You just got promoted. You're Captain Rickover. Keep tweeting. You're Captain Rickover. All right. So play along here if you can see this guy. So the professor's going on and on and on, and everyone's dutifully taking notes. And then this is Tony's still only a captain. He's a 48-year-old captain. His hand goes up in the air. So raise your hand. And the professor says, "Do you have a question?" And the answer is, "Yeah. What the hell are you talking about? I don't understand a single thing you're talking about." So the professor slows down and re-explains the course. And then another minute or two goes by, and then Captain Rickover's hand goes back up. And the question is, "Do you have another question?" And Captain Rickover says, "No, it's the same question, which was..."
I don't understand what's going on.
"Yeah, what the hell are you talking about?" All right, and then in another few minutes, and the professor's going on, and Captain Rickover's hand goes up again. Exactly, perfect. And one more time, just to really get the group.
What the hell are you talking
Exactly. And so finally the professor loses all respect, even though Captain Rickover is the oldest, highest-ranking officer on the base. And he says, "Well, Captain, maybe for you need a tutorial. Would you like to have one tonight?" So what does Captain Rickover say? Sure. When, where? So anyway, young engineer Ted and Captain Rickover are walking over for the tutorial later that night. And wouldn't you know, not a single empty seat. All the people who'd been dutifully taking notes, nodding their head up and down, especially when the professor said intuitively obvious, they're there too. They didn't understand what the hell was going on either. They just didn't raise their hand. Now, let me just focus on this leadership-led learning for a moment. So Ted Rockwell, that's the guy's name, when he wrote his biography of Rickover called The Rickover Effect, he thinks to himself, yeah, it's amazing. Rickover was the only person in the room who had the courage to raise his hand and say, "I don't understand." Everyone else kept their hands down. And then later in the book, he said, "I thought about it more. Rickover is the smartest guy I ever met. In fact, not only did he know more than all the students in the class, the odds are he knew more about the topic than the professor in the class because Rickover probably read ahead." So why did Rickover raise his hand? He had to demonstrate that's what you do. Because if he didn't raise his hand and say, "This is what you do when things are wrong, you call it out," no one else would. And again, I'll just do a little bit more off this slide. So you think of the Navy, they got a lot of bling on their uniforms. It's a contest between them and the Marines who dresses fancier. But whatever, I'll let them settle it. But you notice Rickover wearing a gray suit. Now, where's he wearing a gray suit to? This is the launch of the USS Nautilus, the first atomic-powered warship in the world. And this is the dedication. He's going inside or coming out for the very first time. But he wore a gray suit. And why is that? So that if you walked in and you're just an ensign, you don't see an admiral's brazen head. "Whoa, I can't say anything. It's an admiral." That's a guy in a gray suit. I'll say something. If you're a civilian, you don't see a uniform. "Oh, I don't want to talk up in front of the uniformed military," and vice versa. I don't want to talk in front of our civilian leaders. Everyone wore gray suits. And it was this thing, and this morning, one of the it was the Target presentation. They're talking about how you deploy this out broadly. Well, here's the thing. You do what Rickover did. He taught Ted how to be an astute problem solver. See a problem, solve a problem, spread what you learned. Young engineer Ted taught it to his engineering crew. His engineering crew taught it out to suppliers and into the shipyards. And guess what? It made it all the way down to young officer Tom 30 years later. All right, so that's the model. Now, again, in the very limited time I have left, let me just give you examples of what happens when you apply this model. So a microchip factory built by Digital Equipment, terrible predicament, running a trailing edge technology, a throughput time is the world standard of 60 some odd days. They're threatened with closure because they're no better than anyone else in the world. A year later, their throughput time is not 60 days, it's 20 days. Their capacity is up, their unit cost is cut in half, and they're making an extra $10 million per month. They don't get closed. Second example, Pratt Whitney. Again, wicked, terrible predicament. They've lost countless contests on the military and the civilian side. Each contest to put their engine on someone else's wing is several $1 billion. You just can't do that all. Well, maybe here with the venture capital. I got to figure that out. Gene, you'll explain to me how that worked? I don't know. But in the rest of the real world, you can't do that over and over again. Pratt Whitney takes this, manage your work to see what's going wrong. When it goes wrong, find out why. When you find out why, tell someone else. Leader-led learning. They take the time to design jet engines from 4 years down to 3, cut in half the engineering change orders, and win the contract for the F-35, the biggest contract in weapons history. Alcoa, dangerous place. That's coffee break at Alcoa. That's not even the work environment. That's before the Keurig cup. All right, now it's a little better. All right. Someone should sell these people a microwave. But anyway, the chance of getting hurt on the job at Alcoa was the world manufacturing industry standard of 2% per year lost work days. Alcoa was able to drive that down to 0.07%. I'll give you a sense of things. At 2%, it means that in the course of your career, odds are better than not that you will get hurt on the job. At 0.07%, odds are you won't even know anyone who gets hurt on the job. All right, so that's the Alcoa story. Now, the guy who ran the guy who ran Alcoa, Paul ONeill, retired and then became Secretary of Treasury. So he takes this, when you do your work so you can see problems, when you see a problem, solve it, and when you solve it, teach somebody. He gets to the Department of Treasury and discovers it takes the federal government 6 months to close its books. What's his reaction to that? Why bother? It's like good for historians. I mean, could you imagine today deciding whether or not to buy a car based on your January bank statement? All right. So anyway, the Department of Treasury takes a 6-month process and squeezes it down to 3 days. Now I asked Paul, I said, Paul, what did you do with the extra 5 months, 3 weeks, and 2 days? He said, well, Steve, here's the thing. We had all these, hyper intelligent people working so hard to get to 6 months. Why don't we use that intelligence to do something else useful? So they started creating real-time data systems. On Tuesday, knowing the sales at the Gap on Monday. On Tuesday, knowing manufacturing at Alcoa certainly, but at General Motors and Chrysler on Monday. On Tuesday, knowing credit card account behavior at Citibank and Bank of America. On Tuesday, what happened on Monday. So when 9/11 happened, everyone's like, oh my gosh, what's going to happen to the economy? Paul ONeill and Alan Greenspan are standing there not with make-believe number, pretend number, what do you think numbers. They've got yesterday's numbers making policy for tomorrow. Huge liberation in the ability of the federal government employees to deliver value to market more quickly. We'll skip healthcare now. It's a very depressing topic. It's just diet and exercise, avoid their clutches. They're terrible people. I just explained the picture. Well, one, I'm out of time, but the other is the picture on the lower left. You're safer base jumping than being hospitalized. I mean, all right, so do that math, All right, so anyway, just last story, quick story here. And this is the one, if I get a very short epitaph someday, this is the story I want to go on. So we're doing this work around healthcare and in Pittsburgh. You see the Paul ONeill, Alcoa, Pittsburgh connection. So we work with Alcoa and then Pittsburgh Healthcare. And then it turns out a couple of our colleagues have wives, friends who are working the hotline at the local women's shelter. And they start hearing back. It's in terms of value to market at speed, it's terrible. Because a woman, here's a pantomime. Lady finally gets the nerve to call up, calls the hotline and says, I realize the guy's a liar. He meant it. He's not sorry. He doesn't love me and it's going to happen again. What do I do? And then the hotline counselor has to say something like this. Well, there are 42 state and county agencies that we have to get lined up to get you, your kids in school and shelter and housing and protective orders, this thing and that thing. 42 agencies, how long is that going to take? And then the answer is, well, if everything goes right, and if anything starts that way, if everything goes right, it's going to take 4 days. And then silence on the other end. How the hell am I going to make 4 days worth of phone calls if he comes home? Click. All right, so anyway, here's what they started doing. Exactly the same thing as Hyman Rickover, exactly the same thing as Paul ONeill. Said, son of a gun, what do we really want? What's perfect? The answer is right away. And how come we don't have right away right now? Because we don't know how. So let's try to get right away, and every time we don't, let's see that as a problem to be solved and then sustain what we've learned. So they took what was a 4-day process down to 4 hours. 4 hours. And this is a much happier situation. Now, let me explain a little bit more beyond this 4 hours. Again, on the theme of more value to market more quickly. So at 4 hours, a lot of people, when they call up with exactly the same question, what do I do? He doesn't love me, he's a liar, da-da-da-da. The answer now is no longer, well, you got these, if everything goes right, 42 agencies. The answer is, don't worry. Thank goodness you finally called. Thank goodness you finally called. Come in now, it's 10 o'clock. By 2 in the morning, you will be settled. You'll have housing and clothing and food, and your education will be lined up, and health care, and we'll have protective orders and legal restraining. All this, just come on in. I'm on my way. I'm on my way. And taking it one step further is that these people start coming in, I'm on my way. They start realizing at the women's shelter, of the people who come in, only 10% had ever come to the women's shelter, called the hotline before. And they should have, right? But it turned out, even though 10% had contact with the hotline before, 100% had had contact with some other agency before. What's that agency? The police. Yeah, of course. We all have it. Ours is Alan. You all have it. It's the neighbor who, hey, Steve, I see your trash cans are left out an extra night. Steve, I see the lights are on in your garage. Steve, is that a lot of foot traffic coming in and out of your house? Your kids having a party? Right, and Alan, the other day I gave this talk, someone said, yeah, Mr. Lowe in my neighborhood, right? But we all have that. We all have our Alan, we all have our Mr. Lowe, and they drive us nuts until we need them. Because they're the ones who dial 911 and say, hey, I hear scream, I hear something going wrong. Can you come check it out? So when the police used to come check it out, what they do, they'd separate the abuser from the victim, say to the victim, what would you like us to do? And the answer is nothing. If you arrest him and he gets out on bail, then he'll come home angry. This is happy. Is happy. But then when you're down to 4 hours and you trained up the police force what to do, they come in on a domestic, separate the abuser from the victim, turn the victim, what do? The answer is, arrest that bastard. Because you've already got me on the speed dial on the cell phone, you've already started the counseling, and I know we're counting down to the 4 hours. So anyway, that's the basic story here, which is, performance is a proxy for knowledge and skill. Knowledge and skill is acquired through learning, and learning is a consequence of seeing problems, seeking problems, solving problems, and teaching someone else what you've learned, and that's wicked hard to do, which is why you need an Hyman Rickover to raise his hand in the front row and say,
I don't know what you're talking about.
I have no idea what you're talking about. So anyway, Gina, you going to spot me a few more minutes to explain why the Seahawks lost and the Patriots won? I guess so. Because a guy this morning, I know, it was the fellow from the ticket place, and he had the Seahawks. Anyway, I apologize to the Seahawks fans. All right, so, all right, so you know how this thing ended. The question is, why did it end this way? So, and for those of you who were asleep the entire month of January, February, March, April, May, and June, here's what happened. With a few seconds left in the Super Bowl and the Seahawks having the ball on second and goal, and the ball in their hand, they should have scored. Everyone's, oh my gosh, they're going to score. And
play clock at 5. Pass is intercepted at the goal line by Malcom Butler. Unreal. Malcom Butler, who almost made the phenomenal play.
All right, that was my screensaver, by the way. For those of you who are Patriots fans, we'll just run that through in the happy hour. But anyway, in terms of apples to apples, level playing field, but getting to the right answer fastest. So let's just dissect the play a little bit. Malcom Butler and the intended receiver Lockett, they started equidistance from the ball. And in fact, you could make the argument that Lockett was supposed to know where the ball was going to be, and Butler, yet he got there first. Now, things we can dismiss. He's faster. At this level, the differences in speed are minuscule over that distance. He somehow figured out what was going on. Your neurological system, all right, in certain states they're getting away with the tip. Thank goodness, 15%. You sit there for hours trying to pay 15%. If I want to go at 18%. I mean, that takes an hour, let alone this. So he didn't intuit figure out his way to the right answer. It has to be he knew where the ball was going to go, and he knew how to get there faster than the intended receiver, which begs the question, how's that freaking possible? They didn't cheat. No. All right, so I have a whole riff on this deflate gate, and it's just really a marketing scheme by the Beavis and Butthead marketing department, but no. No, at least indulge me that there's a lesson here other than cheating. Because at the end of the day, we don't want you to walk off and say, hey, guys, what we got to do is cheat. That's the Volkswagen answer. We're talking about Toyota. All right, so what happened? Again, same starting point, but Malcom Butler gets to the right place faster than the intended receiver. And if it's not athletic talent and it's not figuring it out on the fly, it has to be preparation. And if it's preparation, it has to be coaching. So let's think through the coaching story here. So in terms of coaching, every team has its playbook, which is basically a prediction. If we do these things, this is what's going to happen. And every team has their tests to see what's happening, what's going right, and what's going wrong. But there's something unusual. There's something really unusual about the Patriots. And there was 2 articles before the Super Bowl, one a year in advance. And they compare Bill Belichick to Alex Trebek. And the reason is, being a professional football player, wicked exhausting. You got all the stuff going on, studying the playbook, memorizing the playbook. You got all the stuff on the field. But the thing about the Patriots versus everywhere else is when you're done with the playbook, done with the field, Bill Belichick doesn't let up. He'll say, hey, 2nd and goal. What have the Seahawks done all season? 2nd and goal. What should we do? And if you hesitate for a moment, it's like Hyman Rickover. Moron, fool, idiot, on to the next guy. And it's just nonstop testing to see if you know what the right answer is and how it should play out. But then there was another article about the Patriots again, and it didn't mention anything about cheating. It might be, but it didn't mention anything about cheating. It was, and this is also in advance of the Super Bowl, they said another odd thing about the Patriots. Everyone has practice squads, guys who play from Monday to Saturday, never play in a game. But the odd thing about the Patriots is the frequency they churn their practice squad. And I started getting into why is that? They said, well, look, the reason you have a practice squad is you don't want your offense beating up on your defense, vice versa. So you have a practice squad and they become the tackling dummies. But they said in the Patriots, they take it up a level. They say, well, if we're playing a team that has a guy who's 5'10", 225, can run the 40 in 4.1 seconds as running back, we'll hire a guy onto our practice squad who can do exactly that. So when we practice defending against that play, we have something as close to reality as possible. And if on another play they've got a wide receiver who's got a gigantic arm span and an enormous vertical leap, we'll hire a guy just for practicing that play. And again, not to get it right, but to find out why we get it wrong so we can modify and adjust. So in the case of Malcom Butler, he's lined up constantly. And in the 2 weeks preceding the Seahawks game, the Patriots ran that damn play 100 times. And that's how Malcom Butler and the rest of his team knew exactly what to do. They had run that play and got it wrong over and over and over again, but each time they didn't chase the good cake, they chased the burnt cake and said, why did we burn the burnt cake? Let's make a change in the recipe. Why did we burn the cake again? Make a change in the recipe. Again, this is wickedly hard to do, which is why it's so important to focus on a leader who says, guys, we got to test, not to practice right, but to discover why wrong. So anyway, this, I promise, is my last slide. All right, here's your homework. Be the admiral. Be the admiral. If you really want to deliver more value to market faster than anybody else, you got to do what Admiral Rickover set in place with the nuclear navy. You have to pick your work and predict what you think is going to happen and then test real time what's going wrong. When you find out it's going wrong, you have to chase the burnt cake. Don't throw it away. That's the investment. The cake that's good, what the hell? That just confirmed everything you already know. You got to explain the burnt cake. And for your homework, you don't have to spread this, but here's the other thing. As you try to predict what's going to happen, test to find out where you're wrong and explain wrong. Do it with somebody else. You can't do it all by yourself. And if you really want an organization which has this extraordinary velocity in learning and consequently this incredible game-changing performance, you got to teach others how to do this too. So that's your homework for this coming next week after the conference. Find something critical. Predict how you think it's going to work. At 5:05, predict the results of the 5:15 meeting. Find out why you were wrong and make sure you do this with someone all the time. Admiral Rickover is important. He raised his hand in front of everybody else. So anyway, that's my story. Thank you very much. Go Pats. Yeah, it's on the, you can mention it. Oh.
By the way, does everyone see, if you could applaud if you can see why I admire Dr. Spear so much?
Hey, tweet that to my kids.
And by the way, do you see why this is so relevant to the work that we do? Yeah, absolutely. All right. So thank you so much, Dr. Spear.
You're welcome. Thank you.
And I'll catch you later tonight.
Yes.